Hello everybody, and welcome to part 2 of this series where I'll be showing you how to set up your development environment for writing decentralized applications in Python using Cartesi. Now, the setup here is a little bit in depth just because of the inherent complexity of writing smart contracts in, well, any language. Fortunately, once we get it set up, it's very easy to work with it and to do our development, so please bear with me in this video and make sure you go through the steps one by one. Don't skip anything, I promise you will thank me later. Now, the setup is going to be different depending on the operating system that you're on. So on Windows, it's a bit different, Linux, Mac, etc. Fortunately, Cartesi has some really great documentation, and I'll link 3 guides in the description that I highly recommend you download right now. First one is for Windows, next is Linux, and last is Mac. Now, I'll be kind of running through these and sharing with you the differences between Windows, Linux, Mac, etc. Obviously, it's impossible for me to show you the in-depth setup for all of them as I don't have 3 operating systems running on my computer. I just have one, which is Windows. I'll make everything very clear, but I highly recommend that you actually attempt to go through this document on your own, and you can refer this video if you have any challenges or questions about the commands that are being ran. So again, go down to the description. There's 3 guides, one for Windows, one for Linux, and one for Mac, and they will show you the setup steps for running your first decentralized application, which is already built for you using Cartesi. That's going to be the goal of this video. Get a demo application running on our computer, get the setup fully finished and configured, and then I'm going to start explaining to you how Cartesi works a little bit more in depth and giving you some insight into what it is we're actually going to be doing as we start building our decentralized application. Now, another note, if you have any issues with this installation, please join the Discord server that I'll link below. You can actually contact the Cartesi team directly, and they can help you one-on-one with any issue that you have. Now, I have Windows, Linux, and Mac here. I am running Windows on my computer. Now, the prerequisites for setting up the environment are going to be the same for all of our operating systems. So you can see that generally what we need is Python 3, Node.js, Yarn, and Docker Desktop. If we go over here to Linux, same thing, Mac, same thing. Now, installing these requirements are a little bit different just based on the way the operating systems function. So on Linux and Mac, you're actually running in a Unix environment or a Unix shell. That means you have access to some specific commands and some operating system features you don't have by default on Windows. So on Windows, what we first need to do is set up our WSL environment, in this case WSL2, which is Windows Subsystem for Linux. Now, this is a Linux-like environment that will align with the Cartesi ecosystem, which will allow us to do all of our development. Now, for a lot of you, you may actually be on Mac or Linux. If that's the case, you don't need to do that because you already have the correct shell and the correct operating system. So if you are on Windows, what you need to do is start by installing and configuring Docker as well as WSL2. So it goes through here, right? Manual installation of WSL2. You need to open PowerShell as an administrator, run this specific command. Now, for all these commands, again, just download the guide from the description and you can copy them directly in. You then need to switch from WSL1 to WSL2 if you don't already have that installed by running this command. Restart your computer. And after restarting, you're going to download the kernel package for WSL2. You're then going to set WSL2 as your default installation. And then what you can do is open the Microsoft Store and download the current version of Ubuntu Linux. So if you go to Store here and you type in the search bar, if Microsoft will ever load for me here, Ubuntu, as you can see, I already have it typed in. You can actually download an installation. So you can say I have one owned right here. I don't know exactly what version this is, but this installs this Ubuntu operating system in WSL2. So now I have a Linux-like environment on my Windows computer. So that's the first step if you are on Windows. Then what you're going to need to do is install Docker Desktop. Now this is going to be the same if you are on Linux or if you are on Mac, okay? You need Docker Desktop. You can see on Mac, there's different installations for the Silicon chip, so the M1, M2, etc., or for the Intel chip. Now, after we install Docker Desktop, if we are on Windows, what we're going to do is just open it up. Now, this will be the same on any operating system. So whether you're on Mac, Linux, whatever, you want to open Docker Desktop so it's running. It needs to be running in the background for everything to work. If you are on Windows, you are going to click on Settings, and you're going to go to General, and where it says Use the WSL2 based engine, you're just going to make sure that's checked, okay? So make sure you have that selected. That's going to allow you to access the Docker command within your WSL2 installation. Okay, so hopefully at this point you have WSL installed and you have the correct operating system. Once you do that, a lot of the commands now are going to be similar for both Linux, Mac, etc. Next thing you need is Node.js and npm. Now, you're going to need to do this installation, if you're on Windows, inside of WSL2. So open the Ubuntu terminal. Now, the way you can do that is you can just type Ubuntu like this. Okay, so it's going to actually show you kind of this virtual operating system, and it just will open up. Okay, so that's if you're on, Windows. Again, if you're on Mac or Linux, you just open any terminal environment, and you're kind of already set up. Now, what we're going to do is we're going to install Node.js and npm. I've already ran through these installs. You're just going to copy these commands, okay? So you're going to install npm, you're going to source the bash rc, you're going to install node, and you're going to alias nvm with node. Perfect, okay? If we go to Linux, same thing, exact same commands, okay? If we go to Mac, a little bit different because we're going to be using brew to make sure we have Node.js installed. Great. Next installation step is Python. Okay, so again, same thing. We want to make sure we're in the Ubuntu terminal. Everything we do from this point forward, we're doing inside of WSL. Don't do this in your standard kind of Linux, standard Windows command prompt, PowerShell, whatever. Otherwise, it's not going to work. Okay, so now what we want to do is install Python. So same thing, we're going to sudo apt update, sudo apt install Python 3. That's going to install it inside of our Linux environment if we're on Windows. If we're on Linux, we're going to update and install Python 3. I assume most of you probably already have Python 3, but if you don't, you're going to install it, right? Let me just zoom in a bit here. If we are on Mac, to install Python, a little bit different here, okay? Brew install Python 3. Okay, going back. Next thing we want to do is install Yarn. So again, same thing. Make sure you're in the Ubuntu terminal. We're going to add the Yarn apt repository, and we're going to install Yarn, okay? Next, install Yarn, same commands here on Linux, and on, Mac here, fortunately, you could just use brew and just say brew install Yarn. At this point, you should now have a WSL environment. If you are on Windows, you should have Python 3 installed in that environment. You should have Node.js installed, and you should have Yarn. You also should have Docker Desktop. Docker Desktop is running on your Windows instance, okay? So we installed Docker Desktop for Windows. We tick that box. We're good. On Linux, same thing, okay? Python 3, Node, Yarn, Docker Desktop installed on Linux. Mac OS, exact same thing. If we have all those three dependencies, we are now ready to start running through the steps that are actually going to be the same for all the operating systems, okay? Or at least very, very similar. So keep this reference open because, again, you can always go back to it and you can copy the commands. Now, as we see here, on Windows, very important, for a seamless development flow, it is recommended to not execute Docker commands with PowerShell or the WSL terminal. Instead, open the Ubuntu distribution that you have installed and perform all coding and command execution within that Linux environment. So I've been saying that a bunch of times. Just make sure you do this because that's a mistake that I had plenty of times, which is actually why they put it in this documentation. Okay, so what we're going to be doing here is we are going to create a simple DApp. We're going to run a backend that will interact with the Cartesi Rollups framework, which we're going to talk about later. And we are going to use a basic kind of front end or console environment to send some requests just so you can see how we can send data to a decentralized application written in Python. So I'm going to put this on the left-hand side of my screen, on the right-hand side of my screen. And on the left side, I'm going to have my Ubuntu terminal, okay? I've got Ubuntu open up here. I'm just going to open another instance of this. And actually, to do that, I'm just going to type Ubuntu like that. And I'm just going to combine these. Well, let me combine them. No, it won't. Okay, but I just have two of them open because we're going to need two of them at some point. Again, if you're on Mac or Linux, just use your normal terminal environment. Okay, so I'm going to clear the screen with clear. And the first thing we're going to do here is we are going to launch Docker Desktop to start the engine and run the command to check if this is working. So we're going to type docker build x ls like that. Now, we're going to see that we might get this protocol thing. Don't worry about that. What we're looking for here is that we have the Linux RISC-64 installed inside of this. You can see that I have Linux RISC-64. If you don't see that, so if you don't see it, right, what you're going to do is run this command here. Sudo apt install qmenu user static. Again, don't worry about what that's really doing, but we just need this architecture installed in our kind of Linux distribution. So again, if we go back here, now we're on Linux. Okay, same thing, exact same command. We want to make sure we see that in our terminal like that. Okay, now we want to make sure that we have Git installed. So you can see I have Git installed here. If you don't have Git, you're going to install Git on your machine. You can click on this link right here. Again, in Windows, same thing, Linux, Mac, and install Git. Now what we are going to do is clone a repository that we are going to use for this tutorial that has some starting code for us. Now, the link that's here is actually not correct. I'm going to pop it up here and I will put it in the description. This is the Cartesi Rollups example repository. So it says Rollups example right here. And if we click on code, we can copy that. Again, don't worry, I'm going to put that in the description so you guys can just copy it from the description, okay? But it's github.com/cartesi/rollupsexamples.git. So what we're going to do is we're first going to make sure we're in the folder that we want this to exist in. So you see right here, like I'm in just my home folder. So if I type print working directory, I get /home/Tim. Now, if I want to be in a folder that I'm able to access from Windows because I'm in WSL, what I'm going to do here is, let me get out of this, cd ... cd ... and ls. Now notice here, we got a bunch of stuff appearing. What we actually want to cd into here is mount. Now, this is only if you're on Windows and in WSL. If you're in a normal terminal environment, you can just save this wherever you want, but I'm trying to show you on Windows how you'll be able to access these files. So I cd into mount, then I can type ls, and notice that I have all my drives. So I have C, E, F. So I'm going to cd into my C drive. Notice ls, I got a bunch of files here, okay? I'm going to cd into users, cd into Tim, cd into desktop, and now I'm on my Windows desktop, which is mounted to my Linux environment. So this just allows me to share files between my Ubuntu installation and my Windows installation, which is my host operating system, okay? Now what I'm going to do is just make a directory or cd into a directory where I want to clone this. So I actually have a directory called Cartesi on my desktop, so I've cd'd into there. Now that I'm inside this environment, I'm going to clone the repository. So I think I can actually just paste this command, or actually no, that's just the URL. And I'm going to type git clone, and I'm going to clone this repo. Okay, so that's going to take a second, and I'm going to clone this into Cartesi. And now that we have this cloned, we'll actually be able to work with this and start setting everything up. Again, on Mac or Linux, just clone the repo wherever you want. We're now going to cd into that repo. So the repo is rollups examples. And if I ls, you see that we get a bunch of stuff. Now, to make this a little bit easier for us to see, we can open up a code editor like Visual Studio Code, and we can view all of the different code inside of our folders. You see I have rollups example. Okay, and I've got a bunch of folders inside of here that I can start working with. ERC20, Eco Rust, whatever, or sorry, not Echo Rust, Echo Python, etc. And these are all examples of how to write Cartesi code. Feel free to have a look through it. You can read the readmes and stuff, but I'm going to give you the in-depth explanation. Okay, so now let's open this back up. We've cloned the repository, and what we want to do next is we want to cd into the Echo Python repository, which contains a very simple decentralized app in Python that we're going to work with. So cd into Echo Python, and then clear. Now, I want to make it very clear that all the commands I'm running, again, are from my WSL2 Ubuntu installation. If you do this from PowerShell or from a terminal, if you're on Windows, it will break everything. Make sure you are in your Linux environment. For those of you again on Mac or Linux, don't worry about that. Okay, now that we're inside of Echo Python, we can go to VS Code and we can have a look at our Echo Python. And if we go to echo.py, which is our main Python file here, we can quickly run through some of the code. Now, it's going to seem a little bit confusing, but essentially the way that all of this is going to work is there is a bunch of code that we didn't write. This is stuff provided by Cartesi inside of something known as the Cartesi machine. The Cartesi machine is going to take any data that is submitted on the blockchain. It's going to do something known as a rollup, and it's going to send a bunch of requests to our backend. Now, this makes our backend act very similar to a web server. It's not quite like that, but it's very similar in terms of how we receive and send data. So we have our main loop down here. Now, we're going to run this in a second, but essentially what we're doing is we're waiting to receive some kind of request. Now, the request can be one of two things. It can be an inspect request or an advance request. Inspect simply acts kind of like a GET request, where we're receiving some kind of request to return some data. So someone is saying, hey, I just want to inspect the state of this machine. I want to see, for example, what this variable is. I want to see what players have what balance, whatever, right? Whatever the application is doing, inspecting allows us to view the state. Advanced state is something like a post request or a put request. Could be a delete request as well. Anything that might actually modify the state of the machine. This comes through as a transaction. And what we're able to do is kind of handle this advanced state request and respond to it by doing something specific. We're going to get into this more and more, but the way that our Cartesi machine and really our whole backend, which is what this is right here, think of this kind of like your kind of pseudo smart contract, is it acts as a state machine. And the state is held however you want. Could be in a variable, could be on the file system, could be in a database, whatever you want to do, okay? The state is held. And anytime you get a request, which is an advanced state, you can modify the state or respond to that. When you get an inspect request, you're going to return some data, which is some information about the state of the machine, okay? And this is a little bit in terms of how Cartesi works with security. Since we have these discrete states, we're actually able to reproduce these states and to verify that states are correct. We'll talk about that later on, but that was kind of a very quick primer. Okay, so we've got this backend, which is in echo.py. Now, there's a bunch of other files here. We don't need to look at those right now. What we're going to do is go back and we're going to start trying to kind of run all of this code. So let's open up this. Okay, so there's some explanation here, right? It says advance, inspect, etc. And these are just regular HTTP requests that we're responding to in Python. Now, what we need to do is run the environment. Now, since we're running kind of a blockchain application, well, the first thing we need is some kind of blockchain network. Now, we're not going to run this on a main network like Ethereum because we're just doing development. Instead, what we're going to do is run this on kind of a test network. The test network is just going to be running locally on our computer. Once we run the test network, we are then going to run our backend, and our backend is interacting with the test blockchain network using the Cartesi machine. So the first thing we need to do from this echo Python directory is run this command. So let's copy it in. Actually, I'll just type it. Docker build x bake -- load, okay? From the echo Python directory, we're going to go ahead and run this. Now, this is going to build the entire Docker image, and this is going to get everything set up so that we can start running our test network. Now, the way that things will work is when we run our test network, all of the components that Cartesi requires to kind of work will automatically be deployed on chain. There's a bunch of smart contracts that are kind of running in the background that we don't really need to know a lot about that are allowing us to use this framework so that we can write our kind of DApp logic in a normal programming language. So what we just did here is we just built the whole image. For you, it might take a little bit longer. I believe I have some kind of cache here in my system. Anyways, we've built that. Now what we're going to do is spin up what's known as our node. Okay, this is the Cartesi node, which is running all of the, again, kind of on-chain components that we require for our code to work. Now, it's also going to be running, it's going to be running a few things. Okay, it's not just that, it's running some other stuff for the Cartesi Rollups framework. I don't want to mislead you with my vocabulary, but it's just running everything that we need for development, okay? That's the way to think of it. So I'm going to right click here and just copy in this command and just make sure that you kind of fix all the line breaks here. Because, for example, you could see I had this down on a separate line and that would break, okay? So we're docker compose, docker override, docker compose, a bunch of commands you don't need to understand. Go ahead and hit enter. And you're going to see that it spins up a bunch of stuff and we get some output kind of popping out on the screen, okay? What we're viewing right here is our node, which is deploying a bunch of stuff that Cartesi needs and running kind of a blockchain network for us locally on our computer. Okay, amazing. So that is step one. We've got this running, and we're always going to need this running when we do our development because this is the development server that we're working with, right? The development node. Now that we have this running, we can kind of leave that in the background. We don't really need to worry about it. We're going to open up another terminal. Now, this terminal is where we're going to run the backend. This is the one that we can start, we can stop, and this is where we're really going to do quite a bit of our development. So what we need to do is get back into the same directory we were in before. So I'm just going to cd into it. So cd into mount, C drive, users, Tim, desktop, Cartesi, and then what is this? Rollups examples, ls cd echo Python. Okay, I'm inside of my directory. Now that I'm inside of the directory where this code exists, again, same place that we were here in here, what we're going to do is start running our backend. So first thing we're going to do is create a virtual environment to install all of the Python dependencies. Because again, we're running this in Python, just like we would run any Python app. So we're going to type python 3-m venv.venv. This is just our virtual environment that we're creating, which will store our dependencies. You don't always need to do this, just the first time you spin up an example. So this is going to take a second. I'll be back when it's finished. All right, so now that we have created this virtual environment, if I type ls, you should see that we have a venv, or it's hidden because we have the dot folder. But anyways, there is a .venv directory here. You'll probably see it in VS Code, but that's okay. And what we're going to do is just activate this environment. So we're going to type dot and then .venv /bin/activate like that. Now that should activate the virtual environment and you should see this appearing. You're probably not going to see base, by the way. This is just some kind of thing I have in my WSL installation. Don't worry about that. But we have .venv. Now we're going to install the requirements for Python. So we can type pip install requirements.txt. I'm going to make this pip 3. And we're going to install all of the ones that we need. Again, this will take a second. Once it's finished, I will be right back. All right, so all of that is installed. And now that we have that installed, we're on to actually one of the last steps, which is running our backend. So we're just going to copy this command right here. And what this will do is simply run this echo.py file, but we're just declaring a environment variable that's going to be read by that file. Okay, so that's why we have this text beforehand. Don't worry about it too much, but we're saying the rollup HTTP server URL is equal to localhost port 5004. This is just the port that this needs to be running on for everything to communicate correctly. And then we're running the Python echo.py file. By putting this beforehand, again, it's just declaring an environment variable, which will be read by this file. So we're going to go ahead and hit enter. And you will see here that some stuff starts coming in. Now you can see that I'm getting kind of some requests and some data that you're not going to see. It's just because I have some stuff cached on my system. Don't worry about it too much for right now, but in your case, you should get some output that kind of looks like this. HTTP rollup URL, sending finish, no pending rollup, whatever, right? You can kind of see it's appearing here. Again, don't worry about the stuff that's cached. It's just because I had some stuff running on my system earlier when I was testing this. Okay, so now what we have is the following. We have our node, which is running, and we have our backend. The backend is what's going to handle all of the logic, and the node is what's going to take care of essentially forwarding that logic, logging it, and making sure everything is secure. What we need to do now is need to actually interact with our smart contract application, right? Or with our decentralized application. So the way we can do that is we can send one of two types of requests to our backend. Now let's have a look at these again from our code. So you can see that we have an advance and an inspect. Now an inspect is just querying the state, okay? It actually doesn't require that we go through the blockchain to do an inspect. It's kind of just like viewing event data or viewing logs of a normal smart contract. That's kind of what an inspect request is doing. We then have advance, and advance is actually advancing the state. And anytime we change the state of our machine, this needs to be verified and secure. So this actually requires a transaction on the blockchain. Okay. Now let me show you how we interact with this. So what I can actually do is from any terminal, it doesn't have to be my WSL terminal, I can send a kind of inspect or advanced request to my application. So I'm going to cd into the rollups examples and cd into echo Python. Now, we're not going to go into echo Python. We're going to go into the front end console. The front end console is just a little tool that's built by Cartesi, which allows us to interact with our DApp. Now, remember in the previous video, I showed you a front end I built in React. That was my front end console, right? That was how I was interacting with the application. You can write your own interacting code, or you can just use this one from Cartesi. So I'm going to put this on the left side of my screen here. Let me just make this so we can see it. And we're going to start interacting with the backend. Now to do that, we go into the front end console and we need to install our dependencies. This is a normal kind of JavaScript package. So we're going to type yarn, okay? Just going to install everything that we need inside of the front end console. Once that's done, I'll be right back. Okay, installation is done. We are now going to build the application by typing yarn build. Okay, and now that that is built, we are going to take this command right here. And what this is going to do is send an input to our backend. So I'm going to paste this here. I'm going to close this guide now. Let's open up our backend, which is this. Now, I was just testing this a second ago, so you can see we actually have some output. Anyways, what we typed is yarn input send, and then we're sending a payload, which is just some text. Now, what our backend currently does, and I mean, we can read the code if we want to, is it simply creates something known as a notice. And a notice contains the exact same data that we sent to the application, hence the name Echo Python. We're going to talk about notices, reports, and vouchers, which are important in 1 second. But for now, I just want to make sure that this is working. So what we do from the front end console is yarn start input send. we send a payload, and this is going to essentially trigger the advanced state type of request, okay? So what I'm going to do is hit enter. And when I do that, quite quickly, once this actually sends, you're going to see in my backend that I will actually get a transaction coming through. So it says sending, hello world, this is my first DApp, and then it will say the input's added. Now you can see here it says receive the advanced request data, here's the metadata, here's the message sender, and then we have a payload. Now this is hexadecimal encoded, so we do have to decode it if we want to be able to read it. That's fine, don't worry about that right now, we'll look at that later. The point is that we sent some data, it was received by our backend, and if we actually go over here to our host, or to our node, you will have seen, if you look at all of the kind of data going on here, that a transaction went through, so it was sent using the blockchain, and it was received here in our backend. So our backend is able to respond to that and do whatever it needs to do, again, being sent through the blockchain network. I know this is a little bit confusing, but if all of this works, what I just showed you, you are set up. You are ready to go, and we have everything that we need. Now, the last thing I can quickly show you before I start getting into some explanations of what the heck it is that we actually just did is the following. So what happens is that our backend, so if we go here, backend, is able to generate a few different types of outputs, right? If you're familiar with smart contract development, you know that whenever you have a transaction, you can't actually return data from that. There's no way to return information back to the sender. Instead, what you can do is you can emit events, right? And these events are kind of like logs of what's occurred. Now, in Cartesi, we have three types of things that we can kind of emit or create that can give the user some information about what happened in the backend. We can create something known as a notice. Now, a notice is something that's verifiable on the blockchain network that pretty much notifies all of the users who are interested in the state of the application that something occurred. So a notice could be, hey, this user deposited some money, this user withdrew some money, whatever, something that everyone would care about that we'd actually want to be verifiable. That's a notice, and you actually saw that what happened was when we sent an advanced request here, we created a new notice. Now, these notices, we can view, we can query them, we can have a look at them. Now, as well as notices, we can create a report. Now, a report is what's right here, and a report is essentially some kind of log, some information giving you typically debugging information, or it could be some information about the state of the machine. Something that we don't need to really have stored on the blockchain, that doesn't need to be verifiable, and that is essentially just telling you what happened in the transaction that you sent, or in the request that you sent to the backend. So it could be, hey, there was some issue with what you did. So we generate a report, kind of like an error message that you might get from a regular smart contract. We could also generate a report and say, hey, the data that you wanted stored inside of this report, go ahead and have a look at it, okay? Those are the two types of outputs, notice and report. And we have something known as a voucher, which allows you to interact with other smart contracts, which we'll talk about later on. Anyways, what happened was we generated a notice. Now, these notices we can view. So if we go back here, you can see that we have a command, yarn start notice list. If I run this, what it will do is it will list out all of the notices that have been generated by my backend. So we'll give this a second here, and we should see that we get some kind of output, and it shares with us a list of all of the notices. And you can see that we have these notices. So we sent a payload, right? And said, hello world, this is my first app. And you can see that we're viewing it right here. Now, there's a bunch of other notices because, again, I was telling you I was messing with this later, and we have notices like accepting a challenge. Creating challenges. Remember from the first video, these were some of the inputs that we were sending. So there's a whole log of them, and we can see everything that's occurred. Perfect. So that is kind of the basic idea here behind the setup. I'm going to get more into the explanation so you understand how this works. But for now, we can clear this. We can close that up, and we can start tearing down our development environment. Now, when we tear down our development environment, there's a few things that we need to do. So first of all, we can go to the backend, and we can simply just shut the backend down by hitting Control-C. Okay? Control-C, close it down. That's fine. If we were to start running this again and our node were still to be up here, what would happen is it would actually resend all of the different inputs that are stored on the blockchain because they're securely logged, and our backend would be in the same state it was when we shut it down. So what that actually means is that we can have as many versions of the backend as we want running around the world, decentralized, as many as we want to, and they can all be in the exact same state by viewing the information that's secure that's stored on the blockchain. But all the computations are done off-chain, which is what's giving us that kind of performance benefit. Anyways, we shut down the backend. And we're going to shut down our node by just hitting Control C. Now it's going to stop a bunch of containers here, but we're not quite done. I'm just going to close this. We have this command here. And what this command will do is actually tear down the environment for us and remove logs of what's currently stored in this node so that if we start it up again, we're kind of starting fresh. So it's a good thing to know. You always want to be running this command when you're doing like a new cycle of development, so you don't have all of these inputs that you did previously logged on the blockchain. So we're just going to copy this command in. Now, again, there's some issues with the line breaks, so I'm just going to fix those there. This is, again, deleting some of the containers, volumes, etc. So you can see all these volumes are getting removed, which is what we want. And now we have torn down our environment. Amazing. There you go. That is how you set up your environment for writing decentralized applications in Python. Again, please refer to these guides. I recommend you download them and keep them because they're helpful to share with you the commands that you need to copy and paste. If we're getting started again, we're just going to start from running our backend. So we're literally just going to run the backend. We're going to run our node as well. Okay, so make sure that's up and running. And then we can just use the front end console and we can interact with our application. Okay, so now that all of that is done, let me open up a few pieces of documentation here and I'll start sharing with you exactly what it is we just did and kind of how all of this stuff works. So here is a basic kind of overview of the architecture of how this works. We have a front end. We have some chain. This chain is just a blockchain network, right? Something like Ethereum. We then have our Cartesi Rollups framework. And what that consists of is a Cartesi machine, which has the HTTP rollup server and our backend. Now, the Cartesi machine is a virtual machine that runs on a Linux RISC-V architecture. Now, this machine is very important to the security of Cartesi, which we'll get into later. But for now, what I want you to understand is that what we focus on as the developer here is the front end and the backend, just like we would in a traditional web application. The front end is what's interacting with the chain or directly with our Cartesi machine. What it can do is it can send transactions or advance kind of state requests, which are aiming to change the state of the Cartesi machine. This is something that wants to be verifiable, that we have to pay for, right? We got to pay our gas, submit that to the network, even though it will still be a lot cheaper. And then we have inspect, which again is kind of like a GET request. I just want to see what's going on. I want to inspect the state. I don't need to go through the EVM chain to do that. I can go directly to the Cartesi machine. Okay, so these are the two types of things we can do, right? Advance and inspect, and we're going to look at these more in depth later on. Inside the Cartesi machine, we have the rollup server and we have the backend. Now, what the rollup server is doing is really facilitating the communication between our backend and our EVM chain. And it's doing quite a few other things as well. But what's important for us to understand is that we don't really even need to worry about what this is doing. We just need to focus on our backend. So we need to respond to the advance and the inspect state requests, but that's all we need to do. Everything else from the rollups, the securities, the disputes, etc., will be handled by the machine, the rollups framework, and the rollups server. But what you noticed is that we were receiving requests in our code as just normal HTTP requests. Right? Just normal requests. And we were actually creating requests that were posting or creating new notices, reports, vouchers, etc. So we're able to work in a very familiar environment using an HTTP API, which we'll talk about later on, from our backend, which interacts with the rollup server. Okay, so if we look at our things, right, we have Cartesi Rollups, a set of on-chain and off-chain components that implement an optimistic rollup solution and provide the general framework for building dApps. Cartesi machine, a virtual machine that runs an entire Linux operating system in which the dApp's backend is executed. So anything that can run inside the Cartesi machine, we can write. So we can write in multiple languages, one language, we can use all kinds of stuff. We can use the file system, math tools, etc., because we can write the whole backend inside of this VM. We then have the DApp backend. This is the application's state and verifiable logic, which corresponds to the dApp's smart contract. The backend runs inside the Cartesi machine as a regular Linux application. Front end, the application's user-facing interface, such as a web app, that is the most basic part. Now, there's a bunch more stuff here. You guys can go ahead and read through this just by looking up Cartesi. We have the Cartesi machine, though, which I will quickly touch on. So central to Cartesi Rollups is the Cartesi machine. Now, what this does, code execution, abstraction of infrastructure, flexibility, and scalability. The important stuff here is the following. The Cartesi machine contains discrete states. Now, the way this kind of works is that we run in something known as a RISC-V architecture. This architecture is important, and this is essentially the instructions that are being executed by our code. Now, it's pretty complicated, but what happens is anytime we receive some kind of request, so if we go back to our code here, What we do is we execute some instructions on the CPU or inside of our virtual machine. Okay. Now these instructions, we don't really know exactly what they are as, normal Python developers that don't work in assembly and low-level languages. But when I do things like create a variable or send a request or log some information, these are instructions. Okay. They're executed. Now, these instructions are discrete. It means every single time we receive some kind of input or some inspect or whatever, the instructions we're going to do are going to be the exact same. So that means that if we receive some kind of state, we know based on what we receive exactly what the next state of the machine should be. And we know what the current state of the machine should be based on all of the previous states. I'm not sure if this is making sense, but we start in some state 0. We know what that state is, and it's verifiable what the state is. Okay? We receive some kind of input. That advances us to another state. Only that input would have advanced us to that next state. Now, since this kind of makes our backend act like a state machine, we can actually verify at any point in time if the states being produced by the backend are valid based on the inputs that were sent. And what we do is we store all of the inputs on the blockchain, so those are secure, and then we can verify that what's being produced by our different machines, which are running off-chain, is correct. That is a very, very, very high-level overview of how this works. But if we read through here, state transitions happen deterministically. As I was saying, any state transitioning from one state to another state is deterministic. It will always be the same. Now, as the emulator processes the RISC-V instructions, changing the state of the system to a new discrete state. Determinism. Given the same initial state and input, Cartesi machine will always produce the same output and final state to ensure that the off-chain computations can be verified and agreed upon. To engage with Cartesi Rollups, either interact by sending requests or accessing generated outputs. Now, you can read through more of this if you want, but the general idea is Cartesi machine acts as a state machine. Its state is always verifiable because it's discrete and it is deterministic. That means if we advance the state by some input, any other Cartesi machine should have the exact same state. If it doesn't, that means it's a malicious actor, it's doing something incorrect, and using blockchain technology and consensus mechanisms, we can actually say, hey, what was produced by this Cartesi machine, or someone who was controlling this, some node on the network, was invalid. Kind of similar to how it works in things like Ethereum or any other blockchain network, where if you get some kind of output that is not verifiable, that's not correct, you reject it, right? You don't accept that. And there's some kind of ways of handling that and some validators and stuff like that. We don't need to get into all of it. But the point is to understand Cartesi machine, state machine, can advance its machine discretely and deterministically, which allows us at any point in time to understand if it is valid, the state, or not valid. It also means we can have as many Cartesi machines running as we want. These are all nodes sitting on our network, and they can always have the exact same state because they're simply reading the inputs which are verified on the blockchain network, which is layer 1. All right, so now that we understand a little bit about that, let's go over here and talk about the backend API, which is most prevalent to us as the developer. So what happens in the backend? We have the Rollups framework, which I told you is sitting inside of our Cartesi machine. And we have our backend, again, which is running inside of this Linux VM, which is the Cartesi machine. What the backend will do is it will consistently send a finish request to the Cartesi Rollups framework, which is just working on a simple HTTP API. And when this finish request is sent, it will essentially sit there idle, and it will wait for a new request or a new state, inspect, whatever, to be sent. Now, once we get one of these, the backend can perform all of its logic. It can store stuff, it can delete stuff, it can do whatever it needs to do, and it can generate outputs that tell whoever's using this decentralized application what's going on. The 3 types of outputs it can create are a voucher, a notice, and a report. We've already touched a bit on notice and reports. Voucher we'll touch on in a second. Okay, so you can see here, advanced state. Provides an input to be processed by the backend in order to advance the application's state. This is what needs to be verified on the blockchain and submitted on the blockchain. Inspect state does not need to be handled on the blockchain, and it submits a query about the application's current state. When running inside a Cartesi machine, its operation is guaranteed to leave the state unchanged, okay? We cannot change the state using an inspect request, which is why it's fine for us to just submit this directly to the node and skip over the blockchain, which makes things a lot faster. For inspect state requests, this input data contains only a payload. All right, now let's go through and talk about vouchers, notices, and reports quickly, and then we can wrap up this video. All right, voucher. So a voucher is a combination of a target address and a payload in bytes. It is used by the off-chain machine to respond and interact with layer 1 contracts. So a question you might be asking is, okay, well, if I'm running this Cartesi machine off chain, how do I do things like redeem an ERC20 token? How do I interact with an NFT? How do I interact with other smart contracts or a DeFi protocol? Well, you do that using a voucher. So what you can do is you can submit a voucher, or you can create one from your dApp, and that voucher can then be executed on chain. Now, there's some smart contracts written by Cartesi that do this, but you can see the vouchers can only be executed when the epoch in which they're contained in is finalized. Now, we're going to go back to that and talk about it in a second, but vouchers are your way of essentially transferring assets and interacting with on-chain components. Next, we have notices. Now, a notice is an arbitrary payload in bytes that is submitted by the off-chain machine for informational purposes. Similar to vouchers, when the epoch containing a notice is finalized, a proof will be produced so the validity of the node's content can be verified on-chain by any interested party. Now, a report is an application log or piece of diagnostic information, as I talked about, like a notice represented by arbitrary payloads. However, a report is never associated with a proof and is thus not suitable for trustless interactions. So you don't use a report to verify something is correct or whatnot. You just use it for diagnostic or logging piece of information. Lastly, we have a portal. As the name suggests, you are using a portal teleports assets from the Ethereum blockchain to dApps running on Cartesi Rollups. So let's say I want to send some money to my decentralized application. Well, it's not running on Ethereum. It is running on layer 2. So I need to send it through a portal. That portal will then inform my decentralized application, hey, you received some money, and then you can handle the money however you would in a normal decentralized application. Okay, so that's kind of how a portal works. And there's portals for sending regular Ethereum, ERC20, ERC721, and these other types of ERC20 tokens. Okay, now let's quickly go up here and we can talk about nodes and epochs. So we have nodes, just like we have in any type of blockchain network. And these nodes are the decentralized component, right? We have multiple people. Anyone can run a node if they want. Anyone can be a validator. Anyone can be a reader node in this case, or a user. Now, when we have these normal nodes, user or reader nodes, these are simply just advancing the state of the off-chain machine and making sure that anyone can publicly see what the state of the machine is. So for us to be able to know what the state of our application is, we need to have some nodes running. Just like if we want to know what the state of the Ethereum blockchain network is, there needs to be some nodes that we can access on the Ethereum blockchain that tell us the state. Exact same thing here, except with the off-chain component. Next, we have validator nodes. Now, similar to how validators work on Ethereum or miners work on Ethereum, these are going to make sure that everything is honest, that there's no kind of malicious activity going on, and there is actually some kind of incentive mechanism that goes on here in terms of how validators get paid out, how the gas fee goes there, etc. There's some more complexities in this. We're not going to get into this right now. When we start talking about deployment, we can dive into it more, but understand that there is an incentive mechanism using Cartesi tokens for validator nodes. And then the reader nodes, again, they're just making sure that everything is available. Now, lastly, we have epochs. Now, essentially what happens is all these validator nodes at certain points in time are going to checkpoint the state of the off-chain machine on the blockchain. So we know, okay, at this point in time, everything was valid, everything was secure. However, they don't do this until they reach the end of an epoch. Now, an epoch will contain a batch of inputs that follow the same cycle, so you're not checkpointing every single state update, you're doing it more efficiently. Now, in order to end an epoch, all of the validators need to reach a consensus about the state of the machine after processing all of the batched inputs. Now, once that consensus is reached, they're going to essentially take all of the vouchers, notices, etc., and these are going to be considered final because they are checkpointed on the, on the blockchain network. Now, during this consensus period is when disputes can occur. So, for example, if a validator were to put something onto the network or say, oh, this is the state of the machine, but all the other validators say, no, that's not the state of the machine, like that's not how it works, based on the decentralized and consensus mechanism, then they would reject the state coming from the dishonest validator. I'm hoping that makes a little bit of sense, but there is a dispute mechanism. So if any validator sees that a state is incorrect coming from another validator, they can dispute that state. There is a process where they go through some kind of dispute game. I'm not going to talk about that in this video, and that is essentially the security mechanism. Now, I will leave all of these links in the description so you guys can read them on your own if you are interested. So that was the general architecture and key points that I hope you understand a bit of, so that in the next video, when we start writing code, things are in context and you have some foundation for why it is we're writing code in the way that we are. Now in the next video, we'll start writing our backend. Once we finish that, we'll then move on to the front end. But I just want to make it clear that what we'll be doing is actually using kind of the template that you see right here. Now this might seem a little bit confusing, right? The way that we're doing things isn't 100% clear because we haven't walked through this line by line. And you can see that we have a function, for example, to handle inspect requests, handle advanced requests. We are logging some information. We're creating, reports, notices, etc. Now, this is just using kind of standard Python. We don't have any high-level framework. We're not abstracting away any of the complexity. Now, intentionally, I'm going to show you how to do it this way throughout the tutorial so that you really have a deep understanding of exactly what's going on at the lowest level possible. And then eventually you can move on to start using something known as the high-level frameworks. Now, just to give you an example of what I'm talking about, I'll actually show you how we would write the same code that we just saw using the Cartesi Python high-level framework. Now, really what this is a framework that wraps over top of some of the complexity we just saw and puts things in a more familiar environment for us, typically Web 2 developers. So you can see here, we're using a framework here that's wrapping some of that complexity, and we have things like dapp.advance, dapp.inspect, creating a report, notice. This is cleaner, a little bit easier to understand. And there's a bunch of these frameworks that are being created by the Cartesi community and that you could actually contribute to. So I'll pop open some of the GitHub pages as I kind of just go through the value proposition here. So for example, we have Python Cartesi, which is the one I just showed you, where it gives us a very familiar API and development experience to what we might have in Web 2. We have one for Go Rollups. Now this is just a framework in Cartesi for Go, right, to make things easier. We have another one called Eggroll. Same thing, makes things easier in Go when we work with Cartesi code. Then we have one for TypeScript. This is called droll, right? So these are 4 that you could use. I'll link these in the description in case you want to check them out. And the main advantage here is that these are rapidly being improved to make your life easier as a developer. And you could actually contribute to these because most of them are created by community members. Now, this will also just make it a little bit easier to write the code and have some cleaner code. And it's a more familiar experience for most of us. Last of all, it's going to give you a better ability to unit test your code, which is not something we'll do in this series. But if you were making a production application, you'd probably want to write some tests. So again, the way we're going to do things is without using these frameworks, just to make sure we don't have them as a dependency and we don't rely on some of the abstractions that we don't fully understand. But once we get through all of that, you're going to be an expert in writing kind of the base level Cartesi code, and you can start using these frameworks and actually understand what a lot of the methods and abstractions are doing. Anyways, that was it for this video. If you made it to the end, give yourself a pat on the back. I am excited to bring you on to the next video. We'll start writing some code and some logic. I hope you are too, and I will see you there.